In this video I'm going to show you operational amplifier non-inverting negative level detector. This is called negative level detector because here we are applying the reference voltage, and this reference voltage is negative with respect to this terminal. See, the negative terminal or the negative electrode is in upward direction, therefore this terminal V has a voltage of Vn and it will be minus Vref. And this is called non-inverting detector because we are applying the input voltage in the non-inverting terminal, therefore this terminal voltage is Vp and it will be equal to our input voltage Vi. See, there is no direct connection between output and any of the input terminal. That means the operational amplifier is operating in the open loop mode. So we can write our output voltage Vo equal to A into Vd. What is Vd? Vd is the voltage difference between this terminal and this terminal. So I can write Vd equal to this non-inverting terminal voltage minus this inverting terminal voltage, Vi minus Ref. That means Vd will be Vi plus Vref, reference voltage. Now consider a case when input voltage Vi is greater than negative reference voltage Vref. Look at our input and output waveforms. See, this is our applied input voltage. See, this is our applied input voltage, triangular input voltage with maximum value plus Vm and negative maximum value minus Vm. From this point to this point, this is our negative reference voltage. From this point to this point, our input voltage is greater than this negative reference voltage, and as Vi is greater than this negative reference voltage, that means Vi is most of the time of this interval our input voltage will be positive. If our input voltage becomes positive, that means Vd will be more positive. That means I can write Vd will, let's say, always positive. In that case, when this Vd input voltage difference is multiplied with our open loop gain 10 to the power 5 to 10 to the power 8, when this positive value is multiplied with our this high gain, our output voltage will be in positive saturation voltage. That means Vo will be nearly positive saturation. Now consider a case when this Vi is less than our negative reference voltage. Vi is less than negative reference voltage. That means, see, look at the input waveform. This is our negative reference voltage, and when Vi is less than negative reference voltage, that means Vi will be more negative than this negative reference voltage. As a result, our input voltage difference, see, this when this Vi gets more negative with respect to this negative reference voltage, that means our voltage difference will be negative. And when we multiply this negative voltage with our open loop gain, let's say 10 to the power 8 into minus this negative voltage, our operational amplifier will operate in the negative saturation region. So this is it. When our input voltage Vi is greater than our negative reference voltage, our operational amplifier will operate in the positive saturation region, and when our input voltage Vi is less than our negative reference voltage, our output voltage will be in negative saturation region. From this point to this point, Vi is greater than this negative reference voltage. Therefore our operational amplifier will operate in the positive saturation region. When this input voltage crosses this negative level, that means from this point to this point, within this interval input voltage is less than our negative reference voltage. When Vi less than our negative reference voltage, our VO will be in negative saturation. When this input voltage crosses this negative reference voltage again, that means within this interval our input voltage is greater than our negative reference voltage, so our output voltage will be in positive saturation within this interval. So see, whenever this input voltage encounters our negative reference voltage, it changes its, there is a transition in the output voltage which indicate that there is a negative level that the input voltage has come across. That's why this is called negative voltage level or negative level detector. And let me show you the transfer characteristics. Here our reference voltage is at this position, negative reference voltage, because this is our 0 point, this is our input voltage axis and this is our output voltage axis. The points that are lying in the right from this point, negative reference voltage, that means in that region our input voltage Vi is greater than reference voltage, negative reference voltage. So our operational amplifier will operate in the positive saturation, and the points that are lying in the left, that means Vi is less than our negative reference voltage. Our operational amplifier will operate in the negative saturation region, and our positive saturation voltage will be controlled by positive power supply voltage plus Vs, and negative saturation voltage will be controlled by negative power supply voltage. Okay, that's it. Thank you.